An ion is an atom with a net charge due to the gain or loss of electrons.
An ionic bond is a bond between two elements in which electrons are transferred from the cation to the anion. A covalent bond, on the other hand, is a bond between two elements in which they share pairs of electrons to reach their octet and duet rules. In a formula, the coefficient is a numeral value written in front of an element or a molecule used to show how many of a substance there is. Prefixes are used to define how many of an atom is present in a type 3 compound, 1 being mono, 2 being di, 3 being tri, 4 being tetra, 5 being penta, 6 being hexa, 7 being hepta, 8 being octa, 9 being nona, and 10 being deca.
From any type of model, whether it be 3D, like the Vesper, or 2D, like the Lewis dot, it only takes a small inkling of knowledge to comprehend how to transform it to a formula. The first step to interpreting a model is looking at the elements. Once you have that foundation, the rest of it is sheer basic math. Count the number of that atom there are, and write it as a coefficient to the right of the element.
Here are some examples.
Types of compounds, type 1, type 2, and type 3. Type 1, an ionic compound with a metal from group 1, group 2, and a nonmetal. This is named with the metal first, then the nonmetal second, with its root and a suffix IDE. Type 2, an ionic compound with a transition metal and a nonmetal. The metal is named first with a Roman numeral representing the ion's charge after it in parentheses, and then nonmetal afterward with the suffix IDE. Type 3 is a covalent compound containing two nonmetals. The first element in the formula is named first with a prefix of how many atoms of it are present, and the second element second with the prefix of the number of atoms present in the ending IDE. To determine what elements are present in an atom, you must know how many of that atom there are. Once you have that completed, by doing this, you now have the ability to choose which category of the group of elements lie in, such as type 1, type 2, and type 3. Once you have which type it is, look at the prefix to determine how many of that atom there are. Put those two together, and you get your formula.
These steps to predicting formulas have been around for years, and to this day help scientists form a language of sorts to represent the idea of elements being combined to form a sort of compound. An example of this is when any chemist uses compounds. Instead of writing out each name of the compound, it can be abbreviated into a simple formula. Think of it as a contraction in language arts. It shortens the two words into a smaller, more to the point word.
Produced by Zach Christner. Information provided by Matt Izzo, Andrew Long, and Reese Lynn. Special thanks to Mrs. Whiteman for being cool.